After listening the word radiation, most of the people in the world think of only danger and radioactive decay like alpha, beta, and gamma radiation, the harmful rays that can penetrate through everything and destroy it. But that is just one side of radiation. Today, you will get to know another side of radiation that is so useful and beneficial that you can't even live without it. Radiation is energy in transit. It is just a way of energy propagation through space. Radiant energy travel in the form of electromagnetic waves, with or without medium. It can be categorized as either ionizing or non-ionizing, depending on the energy of the radiated particles. Ionizing radiation. Ionizing radiation refers to a flow of energy in the form of atomic and subatomic particles, or electromagnetic waves that have sufficient energy to ionize atoms or molecules by detaching electrons from them. Examples of ionizing radiation are alpha rays, beta rays, gamma rays, and X-rays. But how these radiations are produced? What are their sources? Cosmic rays from outer space and radioactive materials found in the Earth's crust, including radon gas, releases these types of radiations. Their artificial sources are X-ray machines, nuclear reactors, and particle accelerators. It's important to handle ionizing radiation with care and use protective measures to minimize exposure, as it can be harmful to health in high doses or with prolonged exposure. Ionizing radiation can cause damage to living tissue, potentially leading to conditions like radiation burns, radiation sickness, and increased risk of cancer. The extent of damage is generally related to the dose of radiation received. Despite its potential hazards, ionizing radiation has many beneficial applications, including medical treatments like cancer radiotherapy, sterilization of medical equipment, and power generation in nuclear reactors. Non-ionizing radiation. Non-ionizing radiation refers to any type of electromagnetic radiation that does not carry enough energy per quantum to ionize atoms or molecules. Instead of producing charged ions when passing through matter, non-ionizing radiation has sufficient energy only for excitation, which is the movement of an electron to a higher energy state. Non-ionizing radiation is not a significant health risk. The usual definition suggests that radiation with particle or photon energies less than 10 electron volts be considered non-ionizing. Examples of non-ionizing radiation include near ultraviolet radiation, visible light, infrared, microwave, radio waves, very low frequency, and extremely low frequency. Non-ionizing radiation can come from both natural and artificial sources. Natural sources are thunderstorm lightning, heat and sunlight from the sun, the Earth's natural electric and magnetic fields. Artificial sources are radio frequency radiation used in many broadcast and communication systems, microwaves used in the home kitchen, infrared radiation used in heat lamps, wireless devices such as cell phones, cell phone towers, and Wi-Fi equipments. The maximum they can do is heat the object that is exposed to these non-ionizing radiations. That's why we see our laptops, computer, mobile phones, their chargers get heated while usage. Now it's time for myth-busting concept. Do you know electrical energy is nothing but a type of radiant energy? Let's dive deeper into the relationship between electrical energy and radiant energy. Electrical energy. Electrical energy results from the movement of charged particles, usually electrons, through a conductor. When an electric field created by a potential difference acts on charged particles, they move, and this movement constitutes an electric current. Wires, circuits, and electronic devices serve as conductors for this flow of charged particles. For example, while turning on a light bulb, the electrical energy flows through the filament, causing it to emit light. Also, while charging your phone, the electrical energy transfers from the charger to the battery of your phone. Radiant energy. Radiant energy is carried by electromagnetic waves such as light, radio waves, microwaves, and X-rays. It originates from various natural and artificial sources, including the sun, light bulbs, and electronic screens as we have discussed earlier. Examples of radiant energy are sunlight, a significant source of radiant energy, solar panels converting sunlight into electricity, heat radiated from a campfire, also a form of radiant energy. Microwaves in your kitchen use radiant energy to heat food. The connection, here's where it gets interesting. When charged particles like electrons move through a conductor, such as a wire, they create an electric current. This moving current generates a magnetic field around the conductor as per Ampere's law. Now, if the current varies rapidly, like in an alternating current circuit, it produces oscillating electric and magnetic fields. These oscillating fields combine to form electromagnetic waves, or we can say EM waves. EM waves include radio waves, microwaves, visible light, X-rays, and more. Energy transfer. When you connect an electric appliance, say a light bulb, to a battery, the battery provides energy that goes from battery to the appliance in the form of EM waves. So what is the frequency of EM waves that travel from battery to electric appliance? The frequency of these waves corresponds to the frequency of the electric current powering the appliance. For most household appliances, the frequency aligns with the standard alternating current frequency used in electrical grids. In North America, the AC frequency is 60 Hz, while in India and many other regions, it is 50 Hz. Therefore, the EM waves emitted by most appliances have a frequency close to either 50 Hz or 60 Hz. These EM waves fall into the extremely low frequency range, or we can say ELF range. ELF radiation is considered non-ionizing, meaning it lacks the energy to directly damage DNA or cells. Examples of extremely low frequency emitting appliances are power lines. They emit extremely low frequency radiation due to the AC current flow. Household appliances devices like refrigerators, washing machines, and lamps. Electrical wiring, the wiring in your walls, also emits extremely low frequency radiation. That's all for today. See you in the next video. Don't forget to subscribe the channel.